Should make sure to happy Monday, everybody. How's it going?
Going great out here.
Good. Awesome. Matt, how are you?
I'm doing well. I had a good weekend. How are you doing, Keith? Good to meet you.
Dragging a little bit because I'm dealing with a breakthrough COVID, but I'm on the mend. So I have my tall cup of coffee that I can't smell.
Yeah, that's horrifying. Like,
Yeah.
Well, it hopefully doesn't inhibit caffeine though, right? Because that would be like the worst disease ever.
You would die, Joe. I might as well, actually.
Yeah, I would just send it. So anyway, on that cheery note, welcome Keith to the show.
Thanks, guys.
For people who don't know who you are, do you want to give a quick intro?
Sure. So I'm very much a data science guy and still kind of operating there. So mostly on the predictive modeling side. So a little bit of history actually probably would be interesting because I think it'll be relevant today. I actually started out as an SPSS trainer in the late.
I haven't heard that for a while.
Quite a while ago, yeah. So and initially statistics. I thought I would do graduate work in statistics. It's actually why I relocated to Raleigh-Durham. I had my eye on Chapel Hill because back then, I mean, this is a ways ago, but back then there were, of course, no data science graduate programs that, they didn't exist. So it was kind of the expectation that if you were going to get serious about this, that you would do graduate work in stats. And I kind of feel like I dodged a bullet because that's not the way people think about it now. I mean, I think the computer science side of it is considered more important. Not that the stats side is considered unimportant, but I don't think I don't think most people would want to hire a PhD in stats typically to run their data science, team if it's really, too heavy on the stats side. But then SPSS bought a much smaller company that made what was then called SPSS Modeler and is now an IBM product. And that was a predictive analytics workbench. So very kind of Alteryx looking, kind of a thing, or maybe like NIME, if folks know NIME. So I started using that like in 99 before that kind of flowchart looking thing was a thing. So all those years I've been building models, whether it's predictive models on the stats side or predictive models on the machine learning side. I've always been a model builder.
That's cool. And back in the day, it was just called predictive modeling too. I used to do a lot of that same stuff, and it wasn't called data science or anything. And that's interesting. It's funny how terms change. We'll get to more of that in a bit. But we set it on an interesting format too. We're going to kind of turn the tables a bit, and you're actually going to, I think, more interview us about some stuff. So.
Yeah, I think that will be a lot of fun because the book has been out for a few weeks now. Seems like almost daily. There's a picture of the book on LinkedIn. So congrats, guys, for that.
Yeah,
Seems to be doing very well. But I figure that you've told the book origin story. You've had a chance to do that a couple of times.
Yeah.
And your primary audience, it seems to me, are people that are going to be doing data engineering, but it's not your only audience. Certainly a secondary audience are data scientists like me that are working with data engineering teams, hopefully so they can be better collaborators. That's the hope. So I figured it'd be a lot of fun to really focus on that side of the house, collaboration between data science and data engineering.
Yeah, that sounds great. I mean, I think that was one of kind of a secondary audience for us is data scientists who would be working with data engineers and just wanted to understand what the whole discipline was all about.
But that's our background too, is actually in data science, right? So it was like we kind of wrote the book for ourselves, and like I think part of it was also understanding, okay, so if we were to write a book for our younger data scientist selves, like what would that look like? I guess it would also be like maybe steer clear of ye pitfalls ahead. But yeah, so
interesting kind of side note, but I think quite relevant to what we're talking about is I noticed the show that you were on, Joe, with Bill Inman, and then I caught the show or most of the show that you guys did with Kent last week. Anyway, they're very much part of the crowd that does, Bill not as much as years ago, but there's a conference that happens 4 times a year called the Data Warehouse Institute that I've spoken at a number of times. Now, the reason I bring this up is because it's very much, I mean, given the name, it's very much like a data warehouse event, right? But there's a lot of folks that are on that side of the house that are curious about analytics. So I've been going to that for, gosh, I don't know, 6 or 7 years now. And when I sit in on sessions, the sessions that I sit in on are very much the kind of stuff that you guys are talking about in the book. But when I'm giving my talks, it's usually relatively introductory machine learning stuff, because people on the data engineering side are curious about what's, happened on the data science side. In some cases, just, fairly basic, like a stats 101 or, machine learning fundamentals like decision trees or something like that. So I felt, as I read the book, it felt like this ongoing conversation that I've had almost every lunch I've had with other instructors at, TDWI, where I'm usually outnumbered, where they're basically all coming at it from the data engineering side. And there's only about 2 or 3 of us that are brought in to kind of spice things up with some data science content.
It's good to actually motivate the data engineering. I find increasingly that there's this continuum between data warehousing and what you might consider like the kind of big data machine learning space more. I think back in the days of Hadoop, there was more of a clear division, right? You maybe have your Oracle or SQL Server on-prem system that's just for data warehousing, just for business analytics, and then the other stuff is happening in this big data system. But now it's often the same stack that's used for both.
Hey, Matt, can you turn your mic up just a tad?
Yeah. So a common topic that we talk about when I'm hanging out with that crowd, and I'm sure will come up today, is, on the data engineering side, how is serving kind of the business intelligence, business analytics crowd different from serving the data science, machine learning crowd like me? Because that's a constant conversation when I'm hanging out with those folks, because it's almost like an 80-20 rule thing. And people like me are never part of the 80%. We're the exception, So how much time and energy can you reasonably allocate to the most demanding 2% of your users, which is frankly going to be people like me, right? I mean, I think that'll be one of the interesting topics today. So
yeah, for sure.
You guys ready? Should we jump in?
Let's do this. Yeah.
Yeah.
So first question I wanted to ask you guys is that I very much agree with when you're talking about the definition of data engineering and data science, that they're separate disciplines and that data engineering isn't under some big umbrella, some data science umbrella. And I think the skill sets are different. I think the career path is different. So I'm totally on board with the separation thing. So here's my question. If it's true that for the most part that data engineering is upstream from data science, in other words, you guys are, as the data engineers, are kind of helping to create this environment that hopefully makes it easier for people like me to do what I do. There's this interesting issue, and that is modeling and management. I'm sorry, not the modeling, but the managing and monitoring of models that have already been built. And I suppose that's ML ops, but ML ops has as many different definitions as data science and data engineering does. But a quick anecdote about that software I was talking about earlier is that there was a product called Collaboration and Deployment Services. So all the SPSS modeler geeks that may be listening, we're small in number, but they maybe have heard of this thing. Very, very few people would have ever heard of this. But it was literally a handoff from SPSS modeler that built the models to this model management software that was really quite separate, that really had much more of a data warehouse type skill set to it. So there was this explicit handoff, and I've always kind of thought of it that way. So I was curious about what you guys think after the model is built. So now we're downstream of the data scientist. You've got these models, they're going to accumulate. There's going to be a bunch of them. Somebody's going to monitor and manage them. One, is that what you guys would call ML ops? You mentioned ML ops briefly in the book. And two, who should be in charge of that?
It's actually funny. I'm giving a talk on this right after the podcast at the AI Infrastructure Alliance on the role of data engineering in data-centric AI. So data-centric AI is sort of what Andrew had referred to as sort of the reaction to an algorithm-first approach to machine learning, which has traditionally been the approach over the years, right? Make algorithms and just, because we have a lot of data, we can do amazing things. I think the recognition is data quality does matter. Reliability and consistency in how data is delivered is also important. And so that's one of the things that, talk about and how it relates to your question, I think. And I love Matt's opinion on this too. Data engineering is really responsible for taking raw data ingredients and making them useful for downstream consumption. At the end of the day, that's its own life cycle. I personally see machine learning engineering and ML ops as being a separate life cycle. And for that reason, data engineers, I think, should have an appreciation for and know the mechanics of how ML engineers and ML ops practitioners work, but that's probably tangential to the everyday role of a data engineer. But of course, there's always and it depends answer. I think I see this changing too with the lines between data engineering and ML engineering might become more blurred over time. Matt, what do you think?
Yeah, I think there's still this tricky problem of boundaries, where the boundaries between these different disciplines, data science, machine learning engineer, and data engineer are kind of fuzzy and quite different at different companies. And so in many cases, what we're seeing is that ML engineers kind of do all their own data engineering, right? And so they treat the data engineers as a completely separate discipline, which probably is not ideal because it leads to a lot of repeated work. And then we also see this phenomenon. In theory, the data scientists should always be doing new stuff, right? That's their job. They're hired to find new models. In practice, what often happens is that a data scientist finally gets a model that works really well, right? They work on a bunch of projects and they find one that makes the company $50 million a year. Have statistics to back that up. And then their job becomes, they basically just become an ML engineer who manages that model and monitors it and tunes it. Where in principle, you would like a separate team to do that so that the data scientists can be exploring all the time. But I've seen that numerous times, and it's not the ideal career end that most data scientists want, but it pays the bills. And so it's often what happens in practice.
But how does a data scientist learn the engineering skills to do that? I mean, that's kind of the crux and one of the reasons I think we wrote this book, because how often had we had to stand up pipelines and set up infra to do the job that we were hired to do, but somehow we spend 90% of our time doing everything except the job we hired to do. So,
there's another complication too. What you were saying, Matt, really resonates with me. But something that maybe people don't think about. I've been an external resource most of my career, and we all know the turnover is really quite high. I mean, at the moment, we're going through this crazy great resignation or whatever people want to call it. But let's say, for the sake of argument, I'm part of 2 or 3, I'm internal, and I'm doing 2 or 3 projects a year, maybe. Maybe they overlap somewhat in time. Well, what if I stay with the company for 2.5 years and I'm gone? Somebody's got to inherit, especially if it's $50 million. No one's going to let that just die off, So if you've got 20, 30 models in production, I don't think a data scientist can reasonably be a project lead on a 6-month project while they're also dealing with 20 models, 10 of which they inherited and 10 of which they had some role in themselves. Gosh, if you want to push the data scientist out the door, that's a good way to do it. So are we possibly talking about a third team? Is somebody going to be writing the fundamentals of ML ops, meaning really the model management and monitoring?
I think that both needs to happen, actually.
Yeah. Interesting. Yeah, I mean, Makiko has been writing a lot about ML ops lately, right? We should probably chat with her about this sometime.
Well, Dimitrios' community is 10, last time we check, actually, it's a big community.
Just on ML ops. Yeah.
Yeah, I mean, the ML ops community is giant. What do they have now? I'm just looking at the general channel, and it's 12,000 people, right? So,
yeah.
As I said that, I was just thinking of Makiko, actually, because I believe that's how she defines it, is model monitoring and management. But for me, that's been a big part of why I've always worried about this, is that if I'm an external resource, I can come in for 6 months and help build a model.
Yeah.
But I always warn clients, I say, don't forget about this model monitoring and management. And I bring it up like from the first visit. And I say, by the time I'm done, I hope there's a lot of overlap, like a few weeks between the end of my role before I leave and getting somebody up to speed on this, because you can't have an external resource to model monitoring and management, right?
And it does sound a lot like the problems that DevOps was intended to solve. That is, developers working solo, fully owning their code, not collaborating with other developers, not collaborating with ops, so that if anything happened to them, if they got COVID or something, and the code crashed, no one knew how to fix it, right? And it sounds very similar to that, where it's like, no, we need to socialize the management of these models and the operational responsibilities so that anyone could leave the team and other people can pick up the slack over time.
Cool. So not only are we off to a good start, that could probably be a whole show, which I would love to.
I think so.
We'll get it scheduled. That sounds fun.
Oh, and I was going to just mention one more thing related to that, is that when you get into, it's interesting because when you guys talk about reverse ETL and pushing the scores back, that is one small piece of what we were just talking about. And you guys mentioned that more than likely that lands on the data engineer's desk.
Reverse ETL typically does, yeah. Just taking results from analytical systems too and pushing it back to some sort of a destination or something equivalent to it. Yeah, so it's not quite ML, but in talking with people who have been doing a reverse ETL, it's sort of interesting in that one of my friends made a comment. It feels like the stakes are higher in some ways because now you really have to be right because you're pushing results back to the business, like a lead score or something like that, back to say a CRM, and like you better be sure. Yeah. So there's going to be a lot of wasted motion if you're wrong.
Well, let's think of another example. I mean, Mike, the classic example I use of reverse ETL is an ads platform, right? So doing some scoring and then pushing bids back to Facebook or Google. There's a getting it right aspect, Joe. Like you said, you can blow through a lot of money very quickly if your models are wrong. And then there's a monitoring aspect to like watch what's going on, watch for problems, and then correct them very quickly. And in this case, this fits very much in the domain of data engineering and ML ops, frankly. Like it's very much an ML ops type problem to make sure that you're not wasting tons and tons of money with bad modeling.
Yeah, I've got the next question queued up here, but one final thought on this is kind of my nightmare scenario would be, as an external resource, I build the model, we put into place a way that the scores can be pushed back to the system, but no one's paying attention to the model degrading over time. And that absolutely happens, right? Because when the model is fresh, the number one thing in their mind is getting the scores. And then a lot of times organizations will drop the ball on watching the model degrade. So if the data scientist that built that model has exited, if they're no longer there, probably nobody's watching that. And next thing you know, you're going to have scores that are being pushed out, but the model accuracy has dropped and no one knows. That's like nightmare scenario.
Yeah. And there are other subtleties too. So for example, in online retail, many places, Black Friday is still very important. And when you hit Black Friday, all these sales switch on, and also your audience completely changes, right? The people who are coming to your site change completely. And so in a day, your model can basically break, and that can have bad consequences if you're not paying attention.
All right. So next one. I don't know if this will be quick or not quick, right? But you guys have a great section that I really liked about trying to get into all the different titles, including the C-suite. How is CIO different from CDO and CAO and so on? I think it seems like you guys were pretty careful to not make it too prescriptive. I imagine because you just didn't want to, kind of go there in the book and also because I think that people haven't figured this out yet. So you were more descriptive than prescriptive, but I'm just going to, at the risk of putting you on the spot, kind of imagine that you're doing more, not the kind of book you wrote, but more like a HBR article, or maybe like McKinsey wants you to write one of these, how you should do it, right? Be prescriptive for a moment. Who should the data engineers report to and who should the data scientists report to?
Oh, that is a good question. Joe, do you want to go first on this one? Looks like you have some thoughts. I have a few thoughts.
I was thinking about it actually, and I was like, well, I'm going to have to think a lot about this. It really does depend on the structure of the company. And I'm just going to borrow some thoughts from, my friends, John Thompson and Jesse Anderson have written books on data teams, right? And I think inevitably, it really does depend on who, I guess, who the boss of the data scientists or data engineers also reports to, right? So if it's IT might report to a CFO. That's classically been sort of who that reports to, right? But at that point, then, you got to ask, okay, so what kind of projects are you going to be working on? These are going to be more probably, kind of more, I would argue, probably playing defense type things. You're now a part of the cost center, so to speak. It's the CFO pays more attention to the costs. If it's related to a CDO or CEO or somebody who's more focused on the executional parts of the business, COO is the other one. I think the nature of the work will be different in that. And so who you report to, I think it really depends on the type of company that you're working at. There's not really a one size fits all answer to this, but the type of work you end up doing really does depend on who you report to at the end of the day. So, Matt, what are your thoughts?
So one thought that springs to mind, one of the things we talk about is this notion of a chief algorithms officer. And this is a relatively new notion. I think it started at Stitch Fix. And the idea is that if your company is really built around data science and machine learning, that instead of just putting that under like a CTO role or something, you define a role that's really responsible for that whole area. And so they might have responsibilities that reach into data engineering and other things, but they're responsible for like leading the company's strategy around machine learning and data science and making that a core part of whatever that company does. And I think you could argue that this role maybe even goes back to Google in the early days, right? Like Google was very much a company that was built around the PageRank algorithm. And you could argue that like Larry Page and Sergey Brin together served in kind of this chief algorithms officer role. And so I think if your company is really, if that's your core competency, then maybe you should think about having that kind of role in the C-suite to lead all those initiatives.
Well, I mean, at Berkshire Hathaway, that's how Ajit Jain's been running insurance for a long time. I mean, he was basically hired, I think, on sort of a whim almost back in the day. But Ajit's arguably the best risk assessor in insurance in the world, period. And he has full autonomy. I would say he might be the prototype of what a chief algorithms officer has always been, or chief risk officer. He's not doing data science per se, but he also happens to be running insurance and like the largest reinsurer in the world, and Geico and everybody else. And so, I think he sets a really good archetype for how that's done too. Where if it's at the end of the day, I think you got to make a determination like where is this stuff core to your business, right? And so, obviously, risk is very important to an insurance company. So you're going to want to have like that's you're not going to have that person report to your CFO, for example. That's not the same function, and so. But I don't know if Ajit has data scientists working under him or if he literally is just a one-person show like that. I don't know the answer to that, but
he probably has actuaries working under him, right? Which you could argue, and Keith is a stats guy. I'll be curious to hear your thoughts on this. But maybe you could argue that actuaries were sort of the forerunners of data science in many respects.
That's where I was going to go next with this. Is I think actuaries have always been sort of the data team before there was a data team. And that's a data team also where you had to get lots of training. For example, like 10 years to become a fellow. I mean, you're better off getting an MD if you wanted to save some time and make some money.
Yeah. So two things. There's definitely some overlap, but the thing about actuaries is they're making population level predictions. Yeah. And I think the most interesting predictive analytics is per case. Where I'm making a prediction about an individual claim, and I've actually done some pretty interesting insurance fraud stuff. So I find that generally speaking, there's kind of a disconnect between actuaries and predictive analytics. They just look at the world so differently. Now, that doesn't mean that one can't cross-train because there's so much common knowledge between the two. But there are some big differences.
I think the way the teams were set up, though, actuarial science teams, I think, did set kind of a archetype for how, like dedicated data science teams were probably later set up in some degree. But then again, data science also borrowed a lot from software engineering too, right? And so you have back to the notion of ops and stuff. Like this wasn't really a thing because you're using Excel and actuary stuff. You're not really, or a fancy statistical package, but you're typically not, doing stuff at a level you're going to need like ML ops. Maybe that's changing, and I hope it is. But yeah, so it's interesting. But hopefully that answers your question. I think it really just depends on like what the objectives of the business are at the end of the day, and that's how you kind of structure it. Because again, Conway's law sort of dictates how a lot of these systems and teams will be set up, right? So Conway's law is invent systems. You'll communicate and design systems, around the way that you communicate as a business. So,
oh, by the way, a little bit of a random comment. You mentioned the first chief data officer at Capital One. I'd always heard, and who knows which one is true because we're talking about 20 years ago. I always heard that the first chief data officer was Osama Fayyad at Yahoo. He's told the story about how they said, "Okay, well, you're in charge of data, so what should your title be?"
Okay, oh, that's interesting.
He would actually make an interesting. He would actually make an interesting guest. He was also one of the first co-chairs of KDD. Anyway, interesting.
Nice. That's cool.
Interesting guy. Yeah, for me, the reporting structure, what I always struggle with is that if I'm working with a client and the data scientists report up through IT, usually the mindset is that they're a cost center. And Joe, you were hinting at that. And I think that data science should be a profit center.
Yep.
Like your $50 million project, Matt, that you mentioned a few minutes ago. And wouldn't it be nice if it was always that much? But for me, if it's not, if it's not seven figures, you're not making your money back.
Nope.
So 50 million is actually not crazy. I think
I
think 1 million is table stakes.
Yeah.
If you're not north of 1 million, you're not even making your money back. But anyway, that's why I struggle with it. But I have found absolutely no consistency. I could have 5 clients in a row and not have almost any similarity between them. And maybe it's industry, as you were hinting at, Joe. I don't know, but I
think it's all the above. I mean, just because it's like no two companies are the same either. So, where I see things fail is when you try and take a cookie cutter approach to things. I think that's a recipe for disaster. Like kind of a cargo culting the way you design your teams and all this other stuff. It's fascinating for sure. So
yeah, I guess the one thing I would feel strongly on is I don't think they should report to the same at a low level. Like at a director level or something like that. I think they're fairly independent to keep those career paths and those skill sets separately. But that also could be a topic. Reporting structure could also be a show. So next one. This is kind of getting at the life cycle that you guys spend a lot of time on. This is kind of also this idea that data science is downstream of data engineering, which I absolutely agree with for the most part. But one interesting possible exception is stuff like feature engineering.
Yep.
Because I have no earthly idea what transformations I have to do until I'm waist deep, in the project. And that doesn't mean that I'm not doing transformations on top of your transformations, if that makes sense. But there's been absolutely times that I have to go back to pre-transformation data to get what I need to do my transformations, because the signal's been like aggregated right out of the raw data. I'll give you a quick example where at the client, they thought I was crazy and they just didn't want to honor this request. But it was a cell phone churn, and I wanted to look at the call details. And of course, I don't care about individual calls. I'm not like a police detective. I'm not trying to figure out who they were talking to. But the problem is I was getting the billing summary, but the billing summary was only about stuff that they spent money on, which makes sense. It's the bill. But that's where I was getting most of my data about activity. But I was finding some clients that had something free on their plan, and then they switched to something where it wasn't free anymore, and now it was a la carte spend. And I couldn't figure that out unless I went back to all their activity, not only billable activity. But this was like a really huge deal because there was this code that hadn't been touched for years that took all the raw data and produced the billing summary. And really only the summary information was available to BI or reports or those kinds of things. So how do you deal with, a data scientist that wants to go back like pre-transformation? And probably almost nobody else wants to do that, that 1%, that kind of really demanding internal customer.
I mean, I find that really demanding analysts will do this too, right? Like they see something in the data and like, this is kind of weird, but there's something I can't see here that I need to dig into. I've certainly had that happen. My general assumption is that data scientists or analysts who have those needs will go talk to data engineering and say, hey, can I get my hands on this data? And then typically the feature engineering itself is the responsibility of ML engineers and data scientists. Like they're going to be the ones who are actually hacking on data, trying to find the features. But then depending on the team structure, sometimes it's the data engineers who actually deploy the featureization, if that makes sense. So they figure out the feature modeling, the feature engineering on a laptop, and it's like, all right, let's work together to get this into production so it can work on terabytes of data and work completely automatically, and we can start monitoring it and that kind of thing. I don't know. What are your thoughts, Joe?
I mean, completely agree. I think transformations and serving are sort of this interesting life cycle in its own, right? Because it's very iterative. Like, if you expect that people are going to transform data once and serve it to you, and then that'll be the end of it. I mean, that would be convenient. I would also shudder to think about how lame your data science will be as a result. So it's a feedback loop for sure. But for the people that, I mean, in chapter 9, we talk about serving data. And I think this comes along the lines of, if you want all the raw data, then it's your right as a customer to get that. So.
Yeah. And it's interesting because I wrote down another question further on precisely because chapter 9 is a little bit later on. I was kind of going through the book in order. So let's kind of skip ahead to that particular question. In some ways, is this what a data lake, if it's implemented well, you talk about some cautions about, like data lakes, but is that part of if it's done well, it potentially helps with this problem? That the data scientist that does want something really granular or that wants to go back to the raw data, that maybe that's where they're going to look for it?
Yeah, I think when we talk negatively about data lakes, I think usually what we're talking about is just a completely unmanaged data lake, right? Where stuff is just thrown in there, missing schema information, missing metadata, all kinds of stuff like that. But in general, for exactly this reason, the data lake or data lakehouse concept is useful because you do keep the raw data and it's available when you need it at some point in the future. And you actually keep more metadata to make sure that people can make sense of that data in the future. Yeah. Yep. And going back to what Joe was, I think part of what you're alluding to here, Keith, too, is that there's often this tendency, and maybe you dealt with this in companies you've worked with, sounds like it based on what you're saying, for data engineers to work in isolation and to say, this is what we think everyone needs, and then just work and not give people access to raw data, make it really hard for people to get stuff they need and not respond to customer requests basically very well when they do need
Which is something we don't advise on. We definitely, in each chapter, there's a who you'll work with section, and it's there for a reason. Data engineering is one of these things where we feel, and everything in data really, it should be collaborative. At the end of the day, I mean, if you take the notion of data products, which we also cover, you're creating data products, which means you have to listen to customers, right? Whether the customers are data scientists and analysts or whatever, and those data scientists and analysts also listen to their customers about what they need. So it's all up and down the the food chain, so to speak. And so the last thing we advise is data engineers sort of operate in a silo and sort of willy-nilly just create data sets that they think people are going to need. I mean, we see this happening. I mean, in our consulting business, we see this all the time. The data teams will not talk to the business in quotes, and create data sets and reports that they think the business will need, and the business says, I don't really need this. And the data engineer is like, well, that's nice. I don't really care. I'll keep sending you data you don't need. And so you can kind of see where that goes. I mean, it's pretty obvious, but it's shocking how often this happens. And I don't really have a fix for this. The fix I would suggest is probably the fix that I think people will have a bit of a physical revulsion to, which is just you get rid of them. So
I'm kind of smiling because I did have a client where it didn't affect me on the project. It was an experience that they shared with me that had happened, I guess, about 6 months before I was visiting the client site. They said that they had done this big survey and they had like these town meetings to figure out the kind of data that people needed, because the goal was to reduce ad hoc reporting to zero. Not reduce it to zero. So we're going to have this big conversation. Everybody's going to get their input, but speak now, because you'll never be able to change your mind. We're going to formalize everything. And they said that they spent 3 months on that, and it lasted a week.
Wow.
Yeah.
It was a nightmare. Yeah, that I guess everybody, whenever it brought up, everybody just broke eye contact and didn't want to talk about it again or something like that. I wasn't there. I was hearing this secondhand. This was like talk over coffee in the break room, But yeah, that's when you take it to that extreme. And of course, it's impossible for the data. How on earth am I going to know what data I need until I get the next project assignment?
Yeah. And I think from a team organizational perspective too, it would make sense even to have like office hours where the data engineers say, hey, these are our office hours. And actually, if you want to schedule other time, just let us know. We're busy, but we'll find time. And instead of just telling the data scientists, here's the data lake, good luck with that, sitting down and saying, okay, what are you looking for? Like, let's see if we can find this together in the data and start getting you some of what you need early on before you're even getting into production and getting into building production transformations. A lot of problems in corporate organizational structure would just be solved by more conversations and more communication. Same thing with like the relationship between data engineers and software developers working on a website, say, just actually talking to each other frequently and checking in and figuring out mutual needs would be extremely helpful.
It would be useful. It's interesting too. I was having a chat with Bill Inman over the weekend about, sort of what his, he's been in the data space for a long time. I think he's probably the wisest person that I've met in the data space. And his true north has always been, making sure the data is believable and providing believable data. I thought that was really interesting, and it's one of the things that if I were to, go back to the book and define how data engineering, how you define it, I'd probably say it's also the, delivery of believable data sets, right? It's, but you only get that believability by talking to people, right, and understanding what their pain points are and the use cases and so forth. And that requires, again, strangely enough, back to what we're talking about, communication. I know it's hard to do this, but this is how you provide believable data at the end of the day. So,
well, and it's interesting too, because it makes me think of data observability. I know that a few weeks ago you guys had Kevin Hu on the show, but if your model predictions start getting wacky, clearly it could be that the model degraded, but it's just as likely that one of the input variables has gone off the rails. So it kind of gets us back to who's in charge of data believability. You can do some of that at the source, but some of it might have to be like post reverse ETL, if you get what I mean, right? I mean, it could be that the scores just don't make any sense, and that might be the first hint. So I don't know. We're probably back to maybe that belongs to ML ops, right?
That's an interesting perspective. Yeah, because I think in this early phase of observability, there's been a real focus on just like rule-based observability and maybe some statistics. And at some point, what you really need is anomaly detection, right? And that anomaly detection can happen after your models. It can happen in a variety of layers of the data engineering lifecycle in different places in the data flow. But just looking for signals where it's like something is going way out of bounds here. What's going on? And then you have to drill down to find where the problem actually is from that point. But yeah, that's an interesting idea that your models are actually a really great tool for detecting anomalies. If they start behaving weirdly, then maybe something is going on with the data upstream.
Mm-hmm.
Yeah, there was this wacky experience that I had once where it was only the model prediction that helped us find out that something was funky. I took the delta, so I took the difference between the predicted and the actual, and I made that the target of a model. And we found out, I was working with a client on this, and we found out that the number one predictor of the prediction being completely off the rails was the cost of the product. This was being run on like 80,000 SKUs. Well, here's the weird detail. Well, what the wacky predictions were where the cost of the SKU was under $1, and they didn't sell anything that was under $1. So it was like, what the heck is going on?
Yep.
And it turned out to be replacement parts that were under warranty. So there was either some minimal charge or It was just postage or something or whatever on that. But it's because those weren't used in the training data.
Oh.
But they were part of the, like of the deployment data.
Yep.
Right. So I don't know. This is maybe
but that happens a lot though,
Yeah.
right? And I think it comes back to understanding your data too. And when you're making a model, did you take all these things into account? Did you even know that this was a thing, right? The returns data or not when you built the model, and so but this happens all the time. I was looking through a customer's data set yesterday, actually. They had some questions on pricing and discounts, and when I looked at the data set, I was like, I don't. They're like, should we discount or not? I'm like, I think it's inconclusive, but there's a bunch of different parts of the data we need to figure out. But that analysis is what I would say that's hopefully how you avoid that type of situation too. But it's interesting, the model informs that, and I think it's a pretty good model if it could inform that, because in a lot of cases these things might just go sight unseen.
Well, what was so interesting about in that case is that I was really working for the data engineers and not the data scientists. And the reason is that average accuracy had degraded a little bit. So the mission, as this happens all the time, you're asked to do one thing, but it doesn't really solve the problem. What I was asked to do was to implement like an automated model refresh, because the model had degraded a little bit overall. So the feeling was, well, if we just rerun this thing every night at midnight, then it's going to make the problem go away. I said, well, I don't want to take any action until I understand what the problem is. So that's why we looked at why it was accurate for some portions of the data, but not other portions of the data. So it makes me think that whoever's in charge of, a data observability type thing, if it's upstream of the data scientists, something that you might miss. In other words, an argument could be made, the same person who's looking at data observability should be in charge of model monitoring and management. Or maybe it's a question for Makiko to get her opinion on that. Should that person be in charge of both quirks in the data as well as quirks in model performance? Because there's a lot of similarities.
Well, and it underscores the point that a lot of these boundaries that we set up in our teams, you need them, right? You need different reporting structures for data engineering, for software development, for ML engineering, but they're also artificial. And so you end up creating silos where you really want these teams to work together, because often you're really talking about an end-to-end problem, all the way from where the data is generated to where it's getting served in a model. And there could be a problem anywhere in there, right? And you need to you need to monitor throughout that pipeline and then communicate when problems are found and figure out where the issue is. And in this case, it was like an issue just with the data that was being used for training. It's,
you're totally right, because it could be in the feature engineering too, right? What you guys were saying earlier, that somebody like me might prototype the feature engineering, but maybe it's not scalable.
Yeah.
Well, it sort of brings up an interesting argument too, where I think maybe ML engineering and data engineering, if I were to make a team, maybe they should be on the same team. Because at the end of the day, they're responsible for the life cycle of the data and the infrastructure that manages that data. So possibly not the use cases, which the data scientists and analysts would say they're the more of the doing something with it, but the ML engineers and the data engineers are very much a supporting role. And so in order to, but where in the life cycle do these issues happen, right? So it does bring up an interesting argument too. Well, maybe data engineers are just ML engineers and vice versa. But I would say that in order for you to do that, there's so much that you'd need to know about the respective life cycles and about the tools and just the body of knowledge. You tell me, okay, so a good data engineer, I would say, needs to know certain things. A good ML engineer needs to know a set of other things. To combine these into one person is, that's a lot. That's a pretty capable person and a pretty rare one.
Well, but I think you're onto something, because if you think data engineering, then just in terms of the timeline, data engineering, data science, then ML ops on the end, if we're defining ML ops as mostly model management, right? I would absolutely agree with you that data engineering and ML ops should probably report to the same, might have two different managers, but would report to the same folks, and probably would report to IT. Whereas maybe the data scientist would be off reporting to a CAO or chief algorithms officer or something like that. Because again, the model hopefully is a profit center, but once you're maintaining it, that becomes a cost. right? So, it's really on either end. I think the skill set is very similar. It's the model building itself where the skill set is different enough that it's probably a different career path.
Yeah, and knowing what to look for too, like knowing that your Kafka cluster isn't working is a different skill set than knowing that your model has some sort of a quirk in it that wasn't there yesterday. And this is, and it requires having sort of sort of a sixth sense in some ways too with how models work, and in particular how your models work, right? Because it's one thing to know the mechanics of machine learning, it's another thing to know how those mechanics translate to solving your business problems. So it's a multifaceted answer to it. I think a very interesting question. So
yeah, and I think it's still very much an unsolved problem, right? I mean, one thing Joe and I talk about a lot is the fact that so much data comes from the outside now, right? And so you have a data vendor, be that an ads platform or a SaaS platform or something you subscribe to, and they often change their data without telling you, or maybe they notify you, but you miss the notification, or they don't quite explain very well how that data is going to change. And so you can have model problems that occur from third-party data, or you can have model problems that occur from transformations inside your company, because maybe the data engineers make a small tweak to a model to debug something, but then it breaks something else in the way the data is making it to the model. You can have problems with the model itself. You can have problems with the real world where you're getting the data from, like changes in customer behavior, all kinds of different things. So, yeah.
So I want to talk about something a little different, and this may make you two feel a little bit on the spot, but I think
let's do it.
It's worth.
We do this to other people all the time.
I've warmed you up to it. Anyway, one thing again, when I'm hanging out with the TDWI crowd, a lot of times they'll talk about, hey, like 80% of users or whatever number they believe the number is can live within ad hoc reports most of the time, right? And you're going to need those folks that kind of need those exceptions. And then a lot of times I've heard things where the data scientists are they really need granular data. I mean, it's folks like me often that will want a whole year's worth of data, or more granular than anybody else wants, and all kinds of special requests. And I think it just kind of comes with the territory. But where in your experience have you seen data scientists kind of cross the line a little bit, and it's beyond just they've got a tough job to do, so they have some demanding requests, and it's just like they're not pulling their weight, and they're getting too heavy into like the ad hoc or the granular, and it becomes a time sink.
I guess my take on this question is it depends how that data scientist is deploying their time and what projects they're emphasizing. Where I've seen this be a problem is when data scientists are off doing hobby projects that aren't really going to deliver any value. Like they see some interesting, I don't know, blip in the data, and they spend a bunch of time pursuing that without asking the question, well, does this blip even matter to the company? And then data engineers end up spending a bunch of time serving these requests, and there isn't really like they get an answer out of it, but it's not an answer that moves the needle at all. And I feel like on the other hand, if you can identify value, like somehow if this helps you to serve your customers better, helps you to predict better, then it should be fine to spend time on those things. But it's a tricky question of like identifying what's just a cost sink versus what is actually going to generate profit and bigger value for the company. I don't know. What are your thoughts on this, Joe?
I think it was what's delivered at the end of the day, right? Like I don't mind it if a data scientist spends a lot of time sort of meandering in the wilderness. I think as long as there's at the end of the day, what's the expectation, right? There should be some time allocated to this, because that's how you get to understand some of the nuances of your data. And if you don't know the nuances of your data, then it's you don't know the boundaries of it, really, right? It's like asking you to be an explorer, but all you do is just stare at maps all day and not go out and explore. Like it's similar. So, and part of the the art of the data science is really going out there and pushing the edges. But at the end of the day, I think there also needs to be some expectations set that if this yields nothing, I suppose that's also a win. But at the end of the day, we're also trying to get wins. So let's identify what those are and identify steps towards getting there. But again, part of data is there's if you haven't looked at your data, it's all unknowns. It's as simple as that. And so so it is definitely a balance. I would say but the hobby project stuff, is more of a result of a lack of a clear direction. And you see this with software engineers too, right? Like they'll go and pick the latest frameworks and go nerd out on those at the expense of shipping features. And I think there's some benefit to spending time checking out new technologies. I strongly encourage people to do that. That's actually how you might come up with a better idea for doing stuff. But it's a tension for sure. So
I guess part of it is if they have a sandbox to play in, then maybe, in my experience, sometimes at the beginning of a project, I'll grab a month's worth, some reasonable amount that I can process on my, on my laptop, like a month's worth of pretty much everything, just like select star for everything that happened, across the board last month, so that I can play around with it and not be constantly making, requests. And I try to go multiple iterations on my own before I kick it up to go into production. Like I wouldn't create a feature on a Tuesday and send an email saying, "Hey, let's put this feature into production," like on a Wednesday. I mean, man, you have to be judicious about, how often you're doing that. But you guys were very generous with your answer, because I think, to be honest, there are probably data scientists out there that drive their data engineering peers crazy, and I think that,
and vice versa. So to be fair, yeah. But I think maybe another way of looking at this too is if you work a data scientist at an e-commerce company, right? I mean, spend your time focusing on retail and e-commerce related questions and diving into the data sets related to that. If I find you're like staring at data sets from like the James Webb Telescope on company time, I might have to have a word with you about that. So unless there's some strange relationship where somehow you figured that astronomical data set can help us boost our sales, in which case I'll ask you to explain that. I don't know. I mean,
correlation between solar flares and response rate.
Sure. Yeah. Solar flares in, a very distant galaxy too.
Black hole collisions. Black hole collisions.
But again, I'm the kind of guy, I try and keep an open mind about stuff too, initially, because it's like, as a manager, you don't want to, you don't want to squash good ideas too early. And the good ideas sometimes may seem like really crappy ideas. That's the whole paradox of this. I think if you start trying to shoehorn in what you think are good ideas too early, and maybe with too much emphasis, you're going to kill creativity on your team. And that's the last thing you want. I mean, data scientists, I think math skills to me with data science is sort of a given. Like everyone has all the analytical skills, but I think what makes really good data scientists is curiosity and creativity and solving problems and just exploring things. That's the best ones I've seen have just had a very good knack for that.
What I'll add too, Keith, is that you were alluding to this idea of creating sandbox environments. And I think that's also a very important data engineering responsibility, right? So think about DevOps. One of the responsibilities of a DevOps team typically is to provide development resources, right? Like development environments, so you can do builds as you're working on your code, you can do testing. And if we're not doing that with data science as well, like providing things like notebook servers and sandbox data sets and such, maybe with some appropriate anonymization, then we're slowing down people's ability to develop new models. And so I think it's easy to say, oh, I have 50 other production responsibilities. I don't want to worry about these development responsibilities. But in the long term, in terms of value, having those toys to play with is actually going to deliver a lot, which is exactly what you're alluding to too, Joe.
Yeah. Well, so you're not getting, nobody wants to be dealing with like daily requests. You don't want to be, right. Oh my gosh, it's third day in a row we've gotten an email from so-and-so, So next topic, cloud. And the nature of this question obviously isn't to pick favorites among the platform providers. That's not the nature of my question. But this came up in conversation when I was hanging out with the data warehouse crowd too. I'm just starting to see, it's fairly recent, but I'm just starting to see an expectation that if I'm working with data scientists, a particular organization, that we're going to emphasize, if not use exclusively, the tools associated with their cloud provider. So, that could be Azure with Microsoft or AWS or, whatever, right? Again, this is quite new. I've only been seeing it probably within the last year or so, and COVID's made everything a blur. So maybe it's been a trend for 3 or 4 years.
30 years, yeah.
Yeah, and I've only noticed it for a year. I don't know, but my sense is that when an enterprise makes decisions about the cloud infrastructure, it's really with data engineering, in mind, and IT in mind. But I'm wondering if this could be the beginning of a trend where the analytics and data science folks kind of get taken along for the ride, where once this decision is made over on the IT side, there's a strong kind of expectation. Oh, by the way, we have this relationship now, and all of our data is in there, and your models are going to run faster, or whatever the arguments might be. I'm wondering if you're starting to see this too, and if so, is it a healthy thing, or should we be a little concerned about it? Because again, the potential concern would be is that maybe the data scientists weren't at the table when they chose a particular platform, because I don't think anybody chooses a cloud vendor because it has this or that machine learning algorithm. They're making the decision for other reasons. What do you guys think?
Yeah, that's interesting. I think so. So I have a couple of thoughts here. In general, I really like the idea of having data scientists work more in cloud environments because it does solve certain problems, right? So instead of just having data on your laptop, if you're working on some kind of a cloud server, you can give other people access to that same server. And so you can do things like share data, share code more easily. And so there's less friction in collaboration. I tend to agree that companies are not necessarily making the decisions that are best for data science when they choose cloud platforms. And so maybe that's part of the discussion here, that ML and data science should be pulled into these conversations fairly early. The other thing I'll say is that generally you don't want to just make this a data science free for all. That usually has bad consequences if you just tell the data scientists, here's an admin account just to...
Well, especially with GPU costs in the cloud where they are right now.
And security. That's the other one that terrifies
security
me.
For sure. Big time.
And so you do want a collaboration where, again, like the data engineers and ML engineers are responsible for setting up environments and maintaining security and working with the data scientists to make sure that they have the resources they need. Because otherwise, like it ends up being a free-for-all that's worse than people using their laptops. Like they just end up spinning up a million VMs without any collaboration whatsoever. What are your thoughts, Joe, on this?
Well, I think Sonny has a good point here. He says, I often state that just because I have an enterprise agreement doesn't mean your tool for X is my first choice. And yeah, totally agree. I mean, I think the approach to this is, include data scientists in this discussion. In fact, right before we started the show, I was on a call with a client, and they were, trying to figure out which cloud to move to, and the discussion was very much, okay, so we're going to be doing machine learning at some point. I was like, okay, that's a good consideration, and they kind of explained what they'll be doing and so forth. And so, I would say having all stakeholders at the in these discussions early on is how I would advise doing it. You can, of course, do this the other way, where you just say, we're in AWS, for example, and that's what you get to use, and these are the tools you get to use, and that's that. And certainly you can do whatever you want in AWS. If the mandate is, you have to use SageMaker, and you have to use all managed AWS services, and of course that limits the the tool set that a data scientist and the team can use, and so hopefully data science teams have a bit of pushback on this, because I mean, ideally they should know what they need to do their job. I mean, I don't know. It's like going to my car mechanic and saying, look, I mean, I really need you to use these tools that I've provided for you. He'd be like, you can go somewhere else. So
very cool. I recognize Sonny's name, by the way. Thanks, Sonny, for the
Sonny's cool.
For the comment. So I've got kind of a fun one to end on if we have time.
I've got a few minutes. We can go a couple minutes over. Yep.
Okay, I like this. Like this quote towards the end of it's in chapter 9. I think it's in chapter 9. I think it's in the serving analytics thing. What's this? Data is the silent killer.
Sort of like flatulence. Just kidding. What we mean though is data has. There's a lot of things. So if you don't know what's in your data, you might be making decisions off that data and I've seen this happen, for months or years even. And you come to find out that data is wrong. Something happened. I don't know what it is. It doesn't matter. It's wrong. And so when you start hearing things like, oh, well, the reports that we have are directionally correct, for example. That's a good sign that something happened in the data where maybe you just have issues, right? And so that's what I mean. I've seen cases where, again, you're making decisions off of data, and some of these decisions end up being catastrophic. It's not like it's a point in time thing. It's like over and over, you keep making decisions that are suboptimal to your business. So, Matt, any other thoughts on
Well, and Keith, you were alluding earlier to this idea. You didn't put it this way, but basically models can be a silent killer as well, right? So this is something that terrifies you and terrifies us. You go into a client, you do a really good job of building something, and then the data changes or there's drift, and suddenly that model is effectively making really bad decisions and costing a lot of money. And it's something very similar where with data, you can in 2020 you can have your data in like really good shape so that people are making great decisions. But if you don't keep an eye on things, something upstream can break, the outside worlds can change, and then suddenly that data is giving you incorrect answers because it's not accurately reflecting what's going on in the world.
Yeah, Sonny mentioned missing data in another comment that he made, and we can all imagine a data scientist building a model where they've fixed the missing data and the training data, but then at deployment, missing data is flowing through that model. I mean, I see that all the time where someone's like imputing or whatever, or they're using imputation in some AutoML tool. So their training data effectively doesn't have missing data anymore.
Yep.
There was missing data in the raw data, but not in the training data. And of course, this is something you learn and it's kind of expected, but a lot of times that person either isn't around or isn't thinking forward, and then you're deploying and that data is going through. Anyway, we could come up with a gazillion reasons.
Oh, for sure.
Why models look good on the whiteboard and then fail later. Anyway, I thought this was a lot of fun.
Yeah, thanks a lot. Yeah, thanks. It's great. We'll have to have you back when we interview you next time. But
oh sure.
Yeah. So I think there's plenty of material to go from. But you have a good stage presence about you. So yeah, it'd be a lot of fun.
I would enjoy it. I would enjoy coming back. Sure.
Yeah, thanks for being on.
Lots of great questions too, and so I'm sure you have great answers. We'll have to come up with some questions for you that cross over between data engineering and machine learning engineering.
Well, and who knows, if we get lucky, we may get some very cool comments, under the show on LinkedIn, or I don't know how often the conversation kind of continues over there, but that'd be fun to see if that materializes too.
For sure. Cool. Speaking of shows, coming up this week, I'll be on the the Modern Data Show on Wednesday. I'm not sure if that's pre-recorded or not, but anyway, then Utah Data Engineering Meetup this Wednesday night at 6:30 p.m. Mountain Time. We have none other than Bill Inman. He'll be talking about text analytics. So if you're interested in that, check it out. Plus, it's just a chance to chat with a legend and of the field. So the other thing I talked to him this weekend, I didn't know that he invented ETL. That's kind of interesting too, and that both these things almost never saw the light of day.
I didn't know that.
Yeah, it's kind of nuts. Yeah. Anyway,
he's got great stories. He's a great storyteller.
Oh, geez, yeah.
I love that paving the road thing. It had something to do with data architects or whatever, but the paving the road story, I know that. Oh, it was the show that you and he were on together, Joe.
Oh, yeah. With architecture and everything, yeah.
A lot of times with his stories, about halfway through, you go, where is this going? And then he ties it into the topic, and you go, aha.
I swear he's like Yoda. It's crazy. So he'll be at the Utah Data Engineering Meetup. That'll be it's virtual, so just show up. There's Q&A. It's live. So let me see. And on Thursday AM, we're on the Critical Start webinar. Matt and I will be talking about actually data engineering and security and how these things relate to each other. So that's going to be pretty fun.
It's going to be a fun one. I'm excited, actually.
Yeah, that will be fun. It's a bit of an interesting take. No Monday morning data chat next week because I'll be in Australia. We'll be speaking at Data Eng Bites in Melbourne and Sydney. So if you're in the land of Oz, come say hi. We'll be doing a book signing and all the other fun stuff. Then back on the 3rd, we have Omar from Roche. Actually, Kent Graziano recommended that he come on because he had Omar's had some great success from with data mesh, and lots going on. Lots going on now. So and then we'll be in New York City on the 11th at a Data Driven NYC, which is Matt Turk's Meetup. So anyway, lots going on, and that's a small fraction of what's going on. So.
And Joe, do we know if there will be videos of any of your talks in Australia or the Data Driven? I think Data Driven NYC will be online at some point.
I don't know. Maybe it will. Maybe it won't.
We'll post something about it if it is. So yeah.
Yeah. So anyway, yeah. Thanks everybody. Thanks to the audience. Great questions. Keith, again, great questions as well. So looking forward to chatting more. So
yeah.
Cool. All right.
Yeah, I had a lot of fun with it. Thanks, guys.
Awesome.
Thank you.
All right. Happy Monday. See you again.